Hello, here we'll be dealing with partial fractions. So we will have integrals where it will not be easy for us to use change of variables or to use integration by part. So here we apply the rule of partial fractions. So from here, let's say we are given the integral of this form here, then we have to look at the polynomial at the denominator. So if you look at this polynomial where we have ax squared plus bs plus c, we have to look at if it's going to be less than 0, greater than 0, or equals to 0. So we have the cases here. We have if this b squared minus 4ac is less than 0. We look at it again where b squared minus 4ac is greater than 0. We also look at it when it is equals to 0. So now I want to use an example to illustrate this partial fraction. Now let's take a look at this question given to us here. We are asked to calculate the integral of the s over x squared minus x minus 2. So the first thing we need to do here is to determine the operator that we have here. That is, we determine this guy here, which is b squared minus 4ac. So if you look at this, a here is giving us 1, then b here is minus 1. Then we have our c to give us negative 2. So if we put in this here, we have negative 1 squared minus 4 into bracket 1 into bracket minus 2. So at the end of the day, we have 1 plus 8, which gives me 9. And this is what? Greater than 0. So we have this. That means the partial fraction is the method of choice. So we're going to use the method of choice here to simplify this. So if we have that the integral ds over x squared minus x minus 2, I can factor out this to give me the integral of x minus 2 into bracket x plus 1. So what I need to do first is use my partial fraction to simplify this into two fractions. So here I have using partial fractions, then I have 1 over x minus 2 into bracket x plus 1. And this is going to give me a over x minus 2, then plus b over x plus 1. Now, I have this to be 1 is equivalent to a into x plus 1, then plus b into x minus 2. If I put in x to equals to minus 1, then I have the 1 equals to 0 plus b into minus 1 minus 2. At the end of the day, I have 1 equals to minus 3b. So that means my b, therefore b is giving me minus 1 over 3. So if I have this, I need to get my a as well. So if I put x equals to 2, that means I'm going to have 1 equals to a into bracket 2 plus 1. Then that is going to give me 0. So if I have that, that means I have 1 equals to what? 3a. So therefore, I have my a equals to what? 1 over 3. So if I have this, I go back to my equation that I have that the integral of the s over x squared minus x minus 2 is going to give me the integral of a over x minus 2 dx plus the integral of b of x plus 1 dx. So all we need to do is to substitute the values for a and b. So if we do that, we have that 1, a is already 1 over 3, so this is going to give me the integral. I have 1 over 3 of x minus 2 dx, then plus I have the integral minus 1 over 3, then I have x plus 1 dx. So if I have that, this is going to give me 1 over 3. Then I have the integral ds over x minus 2. Then I have minus 1 over 3, the integral 1 over x minus 2 dx. If we integrate this is going to give us the natural log. So this is going to be 1 over 3 ln of the absolute value of this guy here minus 1 over 3. I also have the natural log of this absolute value, which is this. Then I add what? Plus my c. So if I apply the laws of natural log, I have that 1 over 3 is going to give me ln into brackets x minus 2 over what? X plus 1, then plus c. So this gives me what I'm looking for. Thank you.